Hiya, and welcome to the next example for one-to-one change of variables. So basically what we're going to have here is we're just looking at another example. So let's break this down and hopefully you remember the things we're going to have to do. So here we have x. We're told that it has uniform distribution on 0, 1. So here you should remember that we have f sub x of x is equal to 1 from 0 to 1 and 0 otherwise. If x is in 0 to 1. And we're trying to solve for this equation. So the first thing to kind of ask is, well, is this increasing or not? And it turns out it is increasing. So if you plug this into Desmos or GeoGebra or a graphing calculator, you'll notice that this is strictly increasing, decreasing, depending on your choice of lambda. And so here we're going to assume lambda is greater than 0, and we're going to ask, well, what is the density of y? So first, as always, we figure out the range. So 1 is range. So I go from 0 to 1, right? This is the range of x. And I'm going to convert this to y where I plug in my number. So I have minus log of 0 over lambda. I don't know what lambda is. And then minus log of 1 over lambda. Log of 0, this is infinity. It's minus infinity. And so since it's minus infinity, minus times minus gives me positive, right? So this is equal to infinity. And then log of 1, this I should do in green, I guess, same color. This is 0. So 0 times anything is just 0. So we get 0, right? So in other words, interval, so our range is, therefore range is from 0 to infinity, right? So this is kind of what our range is going to be. And then we have to solve for x, right, in order to find the derivative. So remember the main function we had is f of y is equal to f of, not d, f of x d over dy over dx. So we need to figure out these functions. So if I have y is equal to minus log of x over lambda, again, I'm going to do the opposite because I find this easier. I have lambda y is equal to minus log of x. So e to the minus lambda y is equal to x. So taking the derivative of both sides, dy over dx, or dy, sorry. This is going to be e to the minus lambda y divided by, no, because you take it from the top, so it's times minus lambda is equal to dx. So what do we end up having? We end up having, therefore, dy over dx is equal to 1 over minus lambda e to the minus lambda y. Yeah. Okay, so if we plug this in, and we also have a value for x, right? If we plug these into our formulas, what do we end up getting? We end up getting, we plug this in, so f of y is equal to 1 is equal to f of x over dy dx, right? This is the equation. So here we're going to plug in dy dx. So we get f of x over square root, absolute value of 1 over minus lambda e to the minus lambda y. And then here, this absolute value removes the minus sign and we'll flip the thing on top. So we get lambda e to the minus lambda y. And then we still have f of x to worry about. But f of x, remember, is just 1. So in other words, we just plug in 1. And that's our density formula. So we get exponential. So in other words, what we just did is this formula, this function, y is equal to minus log of x over lambda, converts our uniform distribution into an exponential distribution, which is pretty cool if you think about it. Like we can convert between distributions using some function. And so, yeah, so notice how even though we used log here, this is not what's called the log uniform distribution. So I know some people are used to what's called the log uniform distribution. This is not it. This is the uniform distribution. And you can kind of see this from this equality here. Okay, so what this means is we can actually use our functions to change a random variable into a random variable of another distribution. So we can change around our distributions, which is pretty nice. It's something cool we can do. One thing that we can't change is that this change of distribution is dependent on the function. So, and what I mean by dependent on the function is this sentence. Oops, wrong color and wrong sentence. If x and y have the same distribution, then g of x and g of y are also going to have the same distribution. So it can't magically have two things of the same distribution and have them change into two totally different things. If it changes it, it always changes it in the same way. So in other words, here, if I started off with a uniform distribution, I'm always going to get an exponential because that's basically what I got here, right? And so that's what we mean when I'm saying that it's dependent on this choice of function. Anyway, so we'll stop this video here. And in the next video, we're going to look at not just one-to-one, but many-to-one. So where we have things that kind of change and it's not just either strictly increasing or strictly decreasing. So I'll see you in that video. See you then.